Hello guys, I'm Aloko Enoch. Welcome to my math tutorial class on mensuration. In this tutorial, I'll be taking a look at different content. The first one is I'll be taking a look at 3D and representation, 3D shapes and representation. So 3D are solid shapes, guys. Okay. So two, I'll be taking a look at properties of 3D shapes. And property of 3D shape, we'll be talking about the vertices of 3D shape. Vertices are where three lines meet. Then the edges are where two plane shapes meet, and also the faces. So we'll be talking about the properties of 3D shapes. Then finally, I'll be taking a look at how to find the total surface area and volume of any given 3D shapes. Okay, so if you look at this, we have properties of 3D shapes. I have cone, sphere, tetrahedron, cube. Okay, if you look at these are you can actually differentiate these 3D shapes. Okay, we have prism. Okay, prism has a rectangular lateral faces, or better still, rectangular side faces. So example of prism is a cuboid. A cuboid is a cuboid can be a square based prism or a rectangular based prism. Okay, and also prism has two bases or cross section. Okay, so you see the cross section area too. Okay, then second or two, we also can take a look at this. Is a pyramid. It is a square based pyramid because the base here is a square. So, and what is a pyramid? A pyramid have a triangular lateral faces or side faces, triangular side faces, unlike prism. Okay, so unlike prism that has a kind of rectangular or a square lateral faces. So finally, a polyhedron. What is a polyhedron? A polyhedron can be a special type of prism or pyramid, um, which or a prism is a polyhedron, which means all faces are flat and there is no curves, no curved surface. Okay, or no curved side. Okay, so example of a polyhedron is the cylinder. And also when you have all the side, if all the side are similar, like formed by triangles throughout, is this example of a tetrahedron. Okay, so this is also a polyhedron. So let's just get started with properties of 3D shapes. So when I mean properties, we're going to determine the number of faces, the number of vertices, and the number of edges in a given 3D shape. Okay, so let me just start with the first one. Okay, but before I do that, I would like to quickly give you this general formula. Okay, derived by my I derive it alongside my year 7 student, guys. Year 7, because I was trying to look at the best way to actually um, communicate the concepts of 3D properties to them, and try to solve more difficult problems. So we have something like hexagonal based prism, something like octagonal based prism. So without giving them diagrams, so they should be able to deduce or derive. Okay, so that's why I would like to give you this formula, guys. Okay, so generally for prism, let me just write. Generally for prism, I'm not going to write the name of these guys here. I'll just put my formula here, guys. Generally for prism, to determine the number of faces for prism, guys. So faces, don't forget that we have lateral faces. Lateral faces means that side faces. So let me use the word lateral now. So if you want to determine the number of faces, then you have lateral faces plus 2, or side faces, lateral or side. Nice side, yeah, or side faces plus 2. So that is the formula to determine the number of faces. Then if you want to get determine the number of vertices of any given prism, guys, this formula works for any given prism. For any given prism. So vertices. So what are vertices? Okay. So vertices are where three lines meet, three lines. So this is a vertex 1, 2, 3, 4, something like so. Where three lines meet, so 8 for a cuboid, for example. So so that would be 2 times 2 multiplied by lateral faces. So can I say lateral faces times 2? So let's just write lateral means side, guys. So side faces. So for example, if you look at this cuboid now, I mean it's the side 1, 2, 3, 4. So 4 side faces. Okay. So front, back, view, like 1, 2, 3, 4, like that. So lateral lateral, guys, so lateral faces times 2. Okay, this thing is really slowing down. Okay, times 2. And finally, for edges, if you want to determine the total number of edges in any given prism, so that would be lateral faces times 3. So don't forget our lateral faces actually means sides times 3. So I will not be careful to use this. So I'll just apply it to fill and then we go ahead with that. Let me, instead of this this, let me just change to this. Let me change this to properties. Properties. Sorry about that. I should clean it, but I don't know why I'm just too rough, guys. Let me just clean that. I don't know why I'm doing that. Sorry about that, guys. Okay, so properties. Okay, so I want to use this for prism, and I'll use the second one for pyramid. So don't forget that polyhedron is just a special type of prism or pyramid, guys. Don't forget. So because a polyhedron can be prism and a polyhedron can also be a pyramid. So and you know what polyhedrons, okay, you know what they are. Okay, so for pyramid, number of faces will be lateral faces plus 1. So I'm not going to be careful to write this. I'll just put this dash, the same thing, lateral faces plus 1. That is, I copy lateral face here, guys. I just want to be fast. Then for the number of vertices, in this one will also be lateral faces plus 1. So I don't know, am I so lazy? Can I just write this lateral? I don't know why I'm doing this, guys. I'm sorry about that. Okay. Just want to make sure I achieve my objective, guys. Okay, lateral faces plus 1. I don't know, must I write this one to back lateral faces plus 1, guys? Please just pardon me. Finally, for edges, that would be lateral faces times 2. Lateral is, it means side. Let me just write side this time around now. Side faces. So lateral means side faces, guys. It's still the same thing. Lateral means side, guys. Just want to use the word side now. Side faces. Oh, this is slow. So slow, guys. Why is my board misbehaving? Okay, so guys, let's apply this formula and see how it works. So for example, this is a pyramid, right? Okay, this is a cone, yeah, and it's a pyramid. So that's not funny, guys. A cone is a pyramid, guys. A cone is a pyramid. So side faces, okay. So based on the definition, I said number of faces is side faces plus 1, and if you look at this, just a single side plus 1. So this will be 2. So that is for cone, the number of faces will be 2. Number of faces will be 2. Okay, and if I want to get what else can I look for? Vertices and edges for cone. So and if you look at this and I said for vertices it's just one here, lateral faces. Wow, why am I like this, guy? So this is one. So the vertex one, and the edges to one, because we don't have flat face there, so we just have this single, this here and this here. Okay, let me just leave this sphere, guys. But if you want me to work with sphere, yeah, sphere is not a bad deal. There's no flat stuff. We don't have anything like this. So for sphere, the number of faces is one, and the number of edges are no edge guide. I don't have where edges, where where three plane, no plane shape meet here, guys. So that is zero, and vertices is also zero where three lines meet, so there's no three line here. So I can go ahead with this tetrahedron. This tetrahedron is a special type of prism, so I can also apply prism stuff here. So guys, you have to Google. I'm just asking you to do that, guys, because I've been able to confirm to you that okay, this is a triangular base pyramid. Okay, triangular base pyramid, and it's a tetrahedron. Okay, this is also a prism. I can call this one a circular base prism, and it's also a polyhedron or something. This is also a polyhedron, tetrahedron, polyhedron. So these two, so you can confirm if a cone is a, if a cone is a polyhedron or whatever, is a special type of, but you see that this is a vertex, so this is definitely a pyramid, so no problem about that. Okay, so let's go with this now. Side faces, the lateral face, this is a triangle, so the number of side face, our lateral faces, we have three lateral faces. So lateral faces plus one will give us the number of faces. So so 1 2 3 plus 1, so that is 4. Number of faces is 4. Okay, then the number of edges, so based on our formula, number of edges is side faces times 2, or better still, lateral faces times 2. So that will give us number of edges, and side faces we have 1 2 3, so 3 times 2, that is 6. So number of edges, that is 6. Okay, and number of vertices, we said for vertices we have lateral faces plus 1, and lateral faces we have 1 2 3, because it's sitting on a triangle, so 3 plus 1, that is 4. Okay, so let me apply also the same formula for this prism. Lateral faces here is 4, because this the side faces, this side 1, and back, then back and front here, so making 4 side faces all together. So to get the total number of faces, we have side faces, which is 4 plus 2, so that is 6. So the number of faces all together is 6. And for prism also, we say for vertices we should do lateral faces times 2, and lateral faces are 4 times 2, that is 8. So we have the total number of vertices is 8. And for edges, our formula is lateral faces times 3. 4 times 3, that is 12. Okay, I'm not going to apply to this. Cuboid will give me the same thing as this cube. And let me just go ahead and apply to this triangular prism. Probably I will do this. Okay, for triangular prism now, okay, so this is a prism. Since it's a prism, I'm going to apply this formula. So lateral faces plus 2. So the side faces, how many side we have here? We have 1 here, then back. Sorry about that. So side faces, that is lateral faces, not front or back, not where it's sitting. So since it is sitting on a triangle, so the side faces we have 3, 1 behind it and below. So the side faces are 3. Okay, am I correct, guys? 3. So what is, so 3 plus 2, that is 5. So the total number of faces is 5. Don't forget the side faces is 3. So 3 times 2, that is 6. Okay, then 3 times 3, that is 9. So 3 times 3, 9. That means that the edges all together is 9, and the vertices is 6, and total face 5 altogether. So we can, let's just apply to this pyramid. So this is prism. Let's work for pyramid. Pyramid says side faces plus what? plus 1 for total number of faces. So the side faces is sitting on a triangle, so we have the side faces will be 4. So 4 plus 1, 5. So total number of faces is 5 altogether for this square base pyramid. And for the vertices, we have side faces plus 1, so that is 5 also. Then for the edges, we have side faces times 2, so 4 times 2, that is 8. So guys, you can confirm that. Okay, at this point you can just go ahead and try to solve as many as possible. For example, for hexagonal prism, since hexagon, based on the name, hexagon is 6. Okay, so 6 plus 2, that will give me 8. So the total number of faces for hexagonal base prism will be 8 faces. And also for the edges will be 3 times lateral faces. And this is hexagon is 6-sided lateral face, so that will be 6 times 3, so edges will be 18. And also if you want to get the total number of vertices, that will be lateral faces times 2. And since it's hexagon is 6-side lateral face, so that will be 6 times 2, that will be 12. Okay, so you can also apply the same thing to pentagonal base prism. Paint is 5. Okay, so paint is 5, so 5 plus 2, that is 7. So total number of faces will be 7. Okay, so paint is 5 times 2, that is 10. So total number of edges will be what am I talking about, guys? Lateral faces for pentagon, okay, is 5. Okay, so 5 times 2 will give us the vertices, that is 10. And 5 times 3, that will be 15. So that will be for the edges. Okay guys, at this point let's go ahead with it. This question: find the surface area and volume of this. Before I work on this, let me quickly run through a slide, and I don't want to keep writing here because I'm finding it quite difficult to write. Okay, so let's just quickly run through this boardwork. So from the beginning. Okay, so don't forget we are taking a look at solid shapes, and we have 2D representation, that will be plane shape and 3D. So this is a 3D shape. Okay, we have length, height, and width. So don't forget that's faces. So if you have lateral faces, you have 1, 2, 3, 4, and you have edges where 2 plane shape meet, and vertices where 3 line meets. So I explained that before now. So how many faces does a cube have? So don't forget the formula for cube. Since we have 4 lateral faces, so that will be 6 altogether. 6, so that is correct, because that will be lateral faces plus 2 based on our formula. How many edges does a cube have? And based on our formula, edges will be 3 times side faces. Okay, so and the lateral faces we have 4 times 3, that's 12, correct. So how many vertices does a cube have? Since the lateral faces are 4, and based on our formula, we just do it times 2. So 4 times 2, that will give us 8. So that is correct. Hope that is clear. So and that's a cube, and this is a square base pyramid. Okay, in a square base pyramid, since a square base pyramid, okay, so we have 4 lateral faces. So but for pyramid we do plus 1 for faces, so that will be 5. And for vertices and so on and so forth, I derived all those already. Okay, and so we have different type of so you can identify that this is a prism, a pyramid, and a polyhedron is a special type of prism or pyramid. Okay, I think that's a good one. I don't really want to waste much time with this. Do I have something? Okay, don't worry about isometric grid for now. Okay, so let's just go ahead with the next slide and see how to work with that. Okay, from the beginning. Okay, this will give us a better understanding so that we can go back and solve the second question on surface area. But I want to talk about nets, okay, because before you can find total surface area of a given 3D shape, you can actually work based on the net, separate the 3D shape into the different plane shapes, and sum the area of the different plane shapes and combine together to get the total surface area. So now to find the surface area of a shape, you calculate the total area of all the faces. And you know that this is a what? This is a cuboid. So a cuboid has 6 faces. Okay, so the top and the bottom of the cuboid have the same area. So as you can see, the top and the bottom have the same area. Okay, and also the front and the back have the same area. And so a cuboid has 6 faces, and the left and the side, so the left hand side and the right hand side of the cuboid also have the same area. So a cuboid has 6 faces. So now for example, if you take a look at this now, so to find the total surface area of this, we want to calculate the total area of all the faces. So let's just get started. Let's take a look at this. So the area of the top is 8 by 5. Okay, so you can see the top face here, this place. So 8 by 5, and we have 2 because the top and bottom are the same, so just multiply that by 2. 8 by 5 is 40. Also the area of the front is 7 by 5. This is 7 by 5. This dimension is the same thing as this dimension, and that gives us 35. And finally the area of the side face is 7 by 8. So you can see 7 here by 8. So because this side is the same thing as this side, so then what we now do now, we just multiply the top area by 2 because the top and bottom are the same. Also we multiply the front by 2 because the front and the back are the same, and also the side to the left and right hand side like that by 2. So the total surface area will just be 2 times that, so that's top and bottom. Also 2 times 35, that will give us the front and back, and 2 times 56, that will also give us the left and the right side. And so you have 80 plus 70 plus 112, and that gives us 262 centimeters square. So that's how to go about that. Okay, so let me go back to my board. So based on that concept, let's go ahead and solve this problem now. So this seems to be quite a difficult one. So who can tell me, guys, what is the name of this? Is this a prism? Is this a pyramid? Is this a polyhedron, guys? Okay, guys, this is what? Is this a polyhedron? Is a prism? This is definitely not a polyhedron. It's not a polyhedron because the plane shapes are not the same, they are not similar. Okay, we have different plane shapes. Okay, so it's definitely not a polyhedron. Also we can see that we have 2 base, okay, the top and the down, so definitely this is a prism. Okay, so it's a prism. So a prism has a rectangular lateral faces, so you see all the lateral faces are quadrilaterals, guys. But that's not what we want to do, guys. What we asked you to do here is to find the surface area and the volume. So let's get started. So now the first is to go with this. Let me just use this line. So let's quickly go ahead with this one here. So we are going to find the area of this top face here. Don't forget, unlike the sample problem we have from the boardwork, the top and bottom here, they are not similar shape. Okay, so you can see this is the top face now. Okay, so let's go ahead with the top face. So what is the area of this part here of the top face? Because I have this is 2 by let me just use soft pen. Let me use laser so that you can see. This is 10 centimeter here, so this place 2 will be 10 centimeter. So this is 10 centimeter. So mean that the top face is 2 by 10. That is the implication. So the top face is 2 by 10. So let me just go with my art pen. So I have 2 by 10. That's just for the top face. Okay, so plus. Then I think I'll just go with the bottoms because I want to work with top and bottom, because on normal day I should have if it were to be something like a cube, I'll just multiply this by 2, but because the top is different from the bottom, so let me just work with the bottom now, guys. Okay, so let me go with this line again, guys, but don't get this confused. This is the bottom face here, right? So you can I can actually use, but I don't want to carve it out something like this. Close it there, so that will give you the bottom. If but I don't want to mess up the diagram, so that's the bottom, guys. So you see 10 10 6 6. So but let me take it off, I don't need it. Okay, so can I just undo? Don't know the implication of to undo that. Okay, so that's a good one. Okay, so now the bottom is 6 by 10, so that's a good one. So I have the top and the bottom now, 6 by 10. So don't forget, for a prism, the total surface, the number of faces we have altogether would be 6, because the side face is 4, so 4 plus 1, just like what we have in prism. Lateral face plus 2, so 4 plus 1 6. So I have 2 out of 4 now, so I have 4 more. Okay, so through with the top and bottom plus. Let's go for the front and back. The front and back, that is, I want to go for this one now, the front and back. I want to go for this side. This is can I call this one the back, and the front? So if you look at this now, the back and the front are similar, and this is what do you call this one? You call it, is this a prism? A prism? No, what do you mean by, is this a prism? This is prism. So is this a parallelogram or trapezium? Don't mind me. Is this a parallelogram or trapezium? So this is a trapezium. It's a plane shape. So we have two plane shapes here. Okay. So the back and the front, they are similar, trapezium. So how do you calculate the area of a trapezium? You have half times sum of the parallel side times height. So and there are 2. So in that case, let me just put 2 here. So since we have 2 of it, so that will be 2. Okay, I just want to multiply it through, so because they are similar. Then half times sum of the parallel. Okay, half into a plus b. Okay, sum of the parallel side times height. So but I will not be careful to write a plus b, guys. So half times sum of the parallel side. So one of the parallel side is 6, plus the second parallel side, that is 2. Sum of the parallel side, 6 and 2. Okay, then times height. You can see the height is given here 4, so times 4. So guys, I'm good with that. So but I have 6 faces altogether, remaining 2. Because I combine these are similar, that's why I have 2 into this. The top and the bottom are not similar, that's why I have to write it separately, guys. So plus, so the last part is this side. Can I say front or side? This lateral side and behind it, and they are also similar. Okay, and if you look at it, that is what, 10 by 5, and there are 2 of that. So 2 into, because it's a quadrilateral, guys, so 10 by 5, four-sided shape. They are quadrilateral, whatever. Okay, it's cool, guy. I'm almost rounding up, guys. Okay, 10 by 5. Okay, so with this we are cool, guys. So can I just get my calculator here? I don't want my board to mess up. So what is 2 times 10, 20, 20 plus 60. So this guy here gives us what, 80. So I have 80. This is super slow, guy. Okay, 80 plus, so this guy is here. I can have these 2 can cancel out, and if you don't mind, if you want to take it out like that, no problem, you can do this and multiply, but I don't want to do that. I can just take these guys out here, because there are 2 of that. So now I'm left with 6 plus 2. 6 plus 2 is 8. 8 times 4, so what is 8 times 4? So that is 32. So 80 plus 32. And finally, I have 2 into 10 times 5. And what is 10 times 5? 10 times 5 is 50. So 50 plus 50 times 2, that is 100. So I can sum everything all together now. So I have 100 plus 80 is 180. So 180 plus 32, so that gives us 212. So therefore, for this question, and the total surface area for the prism here, and this prism is a special type of prism, it's also known as a frustrum. Okay, it's a frustrum. So 212. And since this is area, so it's going to be centimeter what? Centimeter square. Okay, centimeter square. I know my board is going to mess up. Okay, so I think I'll just what I'm going to do now, I'm not going to allow this thing to I need to keep track of this. Can I keep this somewhere? Can you go up a little more? Okay, guys, that is not funny. Okay, so let me just use my light shot so that I will not freeze screen, and let me see. Okay, before I do that, so that we don't waste much time, okay, let me just go ahead and use my light shots so that I can keep, I just want to keep this page so that I'll keep working on it. Let me just keep this page, so I'll continue from here. I'll just restart the board. So can I save this? Okay, let me just put that, let me save it as continue. Continue, guys. Okay, so save. Okay, I think at this point, because of our time, let me just pause the video, and let me pause the video so that before I restart the board, so you can just pause. Okay, guys, sorry about that. Sometimes my board just misbehave somehow. Okay, so where we are, we now this is so the area, the unit is centimeter square. So finally, we are also asked to find the volume of this shape. Okay, don't forget this is a frustrum, right? Or we can call it a square base prism with top cut off, something like that. So when you have a square base prism and you cut off the top face, something like that. Okay, but it's actually a frustrum. It's cool. Okay, the volume now. The volume and volume is quite easy to find, guys, and I'm going to explain generally. So volume is cross section area times height. Okay, let me take, for example, let's assume that we don't even have this question. If you are working on cylinder, for example, the cross section area, the area of the cross section is this is a circle. So here you'll be having area of a circle, then times the height given here. So let's say the height here is 4, and since this is a circle, okay, it could be a closed maybe open end, or just maybe the top face is open, or the two or the both are open, so it's relative. So let's assume that we have the just the two open now. So you have the area here, you have area of 2 square, and area of a square is pi r square. Do you understand? So if you have 2 open end here, then you have 2 pi r square, then times height. So pi r square times height, or better still 2 pi r. So it depends on if you have that. Okay, for example, if we are working on this triangular base prism and you want to find the volume, and the cross section area here is triangle, so you find area of a triangle. But this triangle we have 2 or something, just this is single one, sorry. So area of triangle, we have is relative. It depends on what the type of triangle it is. Okay, maybe if it has to be a triangle with angle in between here, so you just go ahead with this. So let's assume that you have r base times height, so that will give you the cross section area. Then you have then times height, this will be the height here, times h. Okay, so but if it were to be a triangle such that you can use half AB sine C, provided you have 2 sides with an angle in between, then you go ahead and do that. Okay, so on and so forth. That's how to go about that. So let's work with what we have here. So for this one, what area am I going to work with now? I'll be working with area of what? I'll be working with area of what do you call this? Is it parallelogram or pyramid? Pyramid? What's a pyramid? Is it prism or pyramid? Parallelogram or what? So I just playing, guys. So this that's half into, we have it already. We have the area here, but let me just write it again. Half into sum of the parallel side. So sum of the parallel side, that is 2 plus 6 or 6 plus 2. Okay, then times height. The height there now. So what height are we going to be dealing with now? Because if you look at this one now, half into sum of the parallel side times height. This we are dealing with this shape now. We are dealing with this shape. This plane shape here. So half into sum of parallel, so the height is 4 times 4. And it's not different from this height here. So times height. Okay, so this is the height here, 10, or length. 10 centimeters. Okay, so what do we have there then? Let's this 2 here 1, 2 here 2. Okay, 6 plus 2 is 8. 8 times 2 is 16. 16 times 10, that is 160. Watts is a volume centimeter square. So guys, as I said earlier, guys, what's the difference between a parallelogram and a trapezium? Parallelogram and a trapezium. So guys, please find out, Google, and get to differentiate between the how to find the area. Is this sort of trapezium, guys? Why am I super playful? So so is this a parallelogram or a trapezium? Okay, so I know, guys, I know that this is half times sum of parallel side times height. So it's different from when you have something like this, guys. Okay, what? Don't even try that. Okay, so yeah, this one you have base area times height or whatever, guys. So just find out. Okay, so that's can I just that's a good one. I think we've been able to achieve our objective for today, because we content for today is how to find the volume and surface area of any given 3D shapes and 3D shape properties. So guys, before I call it off, let me just quickly show you this P3. I'll just quickly run through for a better clarification. So now we have prism, pyramid, cylinder, cones, and sphere using a formula. But don't forget, I will not be careful to use this formula. For example, now if you look at this is hexagonal prism and it has same hexagon cross section. So cross section area, if you want to find volume of this one now, you find volume, you find area of, for example, you'll be working with the cross section area, because you have the cross section is an hexagon. Okay, so you are going to work with area of hexagon then times height. But how to find area of hexagon is another problem now, because an hexagon is a polygon, and don't forget a polygon is n minus 2. That's how to find the total number of triangles. You should know that, guys. So if you want to know the total number of triangles in a polygon, in a given polygon, just do n minus 2. And let me give you, for example, if you have a quadrilateral now, four-sided shape, okay, so how many triangle do you have here? We have two. So and it's four-sided shape, so 4 minus 2, that's 2. If you have hexagon, how many triangle we have in hexagon? That will be 4. If you have heptagon, how many triangle we have in heptagon? That will be 5. Okay, so this is octagon or hexagon. 1 2 3 1 2 3 4 5 6. So you have 4 triangles here. So the area now, what you're not going to work with is you have information here. So let's say maybe this point, maybe what you could be given area of one of the triangle. So just do 4 times area of the given triangle. Then the height you'll be working with here will be this one. So that's how to find the volume. And if you want to find the total surface area, just sum area of 2 hexagon plus area of how many this is a rectangles. So area of 6 rectangles. So you have 6 rectangles plus, that is, you are going to find area of 6 rectangles because each rectangle is sitting on the side of the hexagon. So you have 6 rectangles plus 2 hexagon. So you just area of, and how do you find the area of hexagon? By just 4 times area of each of the triangle, provided the hexagon could be given. If it's not given, then probably one of the triangle will be given, or you can just get it also. You can do something like this. You can do that and you finish up. Okay, so that's that. So let's take a look at more. I just want to use this one. So this is called hexagon with cross section. Can you move forward, guys? Let me just show my students some field trip. I don't know why it's a little bit slow. Why are you wasting my time, guys? I think I don't need grid. That's why you're wasting my time. Okay, guys, we solved something like this already. If you want to find the volume of this prism, just go ahead with volume, just surface area of the triangle. Let me just show you. So for cross-sectional area now, you have half base times height. So half base, half is 0.5 times base, 5 times height 4. So you have that. Then the side, the height here is 7. So and that gives you that. Also, if you want to find the volume of this, or if you want to find the cross-sectional area of this one, so you just have area of the big what do you call these guys? Can I call this a rectangular base prism or a cuboid? So you find the cross-section area of the big cuboid, then minus the small one, and if you want to find the volume, then times height. So this is the height here. So guys, at this point I think we need to call it a day. So hope you enjoy my tutorial. Please do well to subscribe to my channel, and do have a great day ahead. Bye bye, guys. Bye guys. Bye bye.